Lever is a system that consists of three key components: axis of rotation, motive, and resistive force. The motive force is the force you need to rotate the lever in a direction that you want. In this class, the motive force usually comes from a muscle contraction. The resistive force is a force that resists the action of the motive force. Using the lever, we can analyze the efficiency of the lever or how much motive force is needed to overcome the resistive force. In an efficient system, you can overcome the resistance force with lesser amount of motive force. In an inefficient system, you will need more motive force to overcome the resistive force. The lever system can be classified into three groups based on its arrangement of the axis, motive force, and the resistive force. The one in which the axis is in the middle and the motive and resistive forces are on the opposite side of the axis is called a first-class lever system. The second-class lever is the one in which the resistive force is in the middle, and the third-class lever is the one in which the motive force is in the middle. An easy way to remember this is by remembering that the letter of the component in the middle of the system goes in the order of A, R, M, or R. The example of the lever shown here is the third-class lever system because the motive force is in the middle. Now let's look at each type of lever. Here's the first-class lever with the axis in the middle. Example of this system in the body are the neck extension system and elbow extension produced by the triceps force. Let's look at the example of the neck extension system. The axis in this case will be the atlanto-occipital joint where the skull sits on the vertebrae. This will be the axis or the pivot point for the neck extension motion. The resistive force in this system is the weight of the head pulling the head down on the anterior side of the axis. Since the weight force is pulling down on the head on the anterior side, it would create the clockwise torque about the axis, or the torque that would cause neck to flex. The motive force is a neck extensor muscle pulling down on the occiput of the skull on the posterior side of the axis. Because the force is acting on the posterior side of the axis, the force would create a counterclockwise torque, or the torque that would cause neck extension. In order for the muscle to extend the neck, the torque in the counterclockwise direction produced by the neck muscle needs to be larger than the torque produced by the weight of the head. The second-class lever has the resistive forces in the middle. This system is what you see in a wheelbarrow that is used to move heavy loads. However, this class of lever is very rare in our body. The third-class lever system has the motive force in the middle. Most of the joints in our body act as a third-class lever system. This is because the muscles typically insert very close to the axis or the joint, and the resistive force is applied further away from the axis. The examples shown here are knee flexion and extension mechanism. The motive force for the knee extension is produced by the quadriceps, which inserts onto the tibial tubercle on the front of the knee. The resistive force in this case is the roller from the knee extension machine you may see at the gym. The resistive force is producing torque that causes knee flexion. The motive force or the quadriceps will need to produce a knee extension torque that is greater than this in order to move the knee into extension against the resistance. Let's look at the right side. This figure is showing the knee flexion mechanism. The motive force for the knee flexion is produced by the hamstrings muscle, which insert onto the posterior tibia or the back of the knee. The resistive force in this case is the roller from the hamstring curl machine you may see at the gym. The resistive force produces knee extension torque, while the hamstring produces knee flexion torque.